Hey, trig class, we're going to look at where does the graph y equals negative 9 cotangent x, where does it cross the x-axis, where are its vertical asymptotes, what are some key points, and we're going to show you, number one, how to do it by hand, and then number two, how a TI calculator can help. So typically, the cotangent function, we graph it between 0 and pi, and those are vertical asymptotes for cotangent. In between the two, at pi over 2, halfway between 0 and pi, we hit the x-intercept. And then halfway between those, which would be negative pi over, or sorry, not negative, positive pi over 4 and 3 pi over 4, we're going to hit our 1 and our negative 1. Let me just draw it like that. Okay, and then this graph goes towards its vertical asymptote as we go left. It goes towards its vertical asymptote as we go to the right. And then you're going to basically copy that, and you'll be able to paste it over and over every period. Add the period. So add the period is pi, so add pi to that. So pi over 4 plus pi is 5 pi over 4. And at 5 pi over 4, you'll be back at that point again. At pi over 2 plus pi, which would be 3 pi over 2, you'll be back on the midline again. And then 3 pi over 4 plus 5, again, that'll be 7 pi over 4. You'll be back to negative 1. Right, at 2 pi, adding pi again, 2 pi, will be another vertical asymptote. And then you'll be able to start it over. Just keep adding pi. And you'll do that over and over again for the cotangent function. Okay, but this isn't just cotangent. This is negative 9 cotangent function, negative 9 cotangent. So instead of, number one, it falling left to right, the negative is going to flip this thing over to where it rises left to right. All right, and the other thing is these will not be 1s and negative 1s out here anymore. It will be 9 and negative 9 because of the negative 9 being out. So it's going to look something like that now that we negated it with a negative sign out in front and put a 9 out there that stretches the graph out. So that's what we should be looking for. So same key points. Those quarter period points are still 0, pi over 4, pi over 2, 3 pi over 4, and pi for the first period. It's just we got stretched vertically by the 9 and then flipped over by the negative. So it kind of looks like a shifted tangent function now. All right, but that's what we're going to be looking for, something rising left to right. So that's rising left to right. But something that has a vertical asymptote at 0 and at pi and at 2 pi. So vertical asymptote at 0, vertical asymptote at 0, vertical asymptote at 0. Vertical asymptote at pi, that one doesn't. So A is out, B is out. So it could be C, it could be D. All right, the problem here is when we are at those quarter period points, the pi over 2, the 3 pi over 2, we're not at 9 and negative 9. We're at negative 1 and 1 here. So that's the reason why D is the one that we're after. Okay, so the vertical stretch of the 9 wasn't present in C. All right, what's the domain? So the domain is everything except those vertical asymptotes. Those vertical asymptotes we're having at multiples of pi. So there is our domain. X, such that x is not k times pi. That's a multiple of pi. All right, that's k times pi over 2. That's odd multiples of pi over 2, odd multiples of pi over 4. Ours were odd multiples of pi, so that's C. All right, and then the range of cotangent. Cotangent has vertical asymptotes. It goes off to infinity, positive and negative. So it is all real numbers is the range. And the same thing happens with the tangent function. It goes off to positive and negative infinity as well.